Alright guys, we wrap up section 11.5, working a little bit backwards from what we have been doing in the first part of this video. Instead of telling you what the center and the radius were, or giving you information about them to be able to write the equation, here we give you the equation, we ask you to graph. Okay, finding the information, probably not all that difficult, and then we'll talk about what we want to see from you to understand that you have a good grasp of what this circle would look like, because we're going to be graphing freehand, so it's not going to look perfect. Okay, x minus 7, this is the h, so this would be our x coordinate of our center. But remember, because there are minus signs in our general formula, this is actually going to reflect a positive 7 for our x coordinate. We're thinking opposite the sign because of the way the general formula looks. Alright, this is our k, or our y coordinate of our center, opposite the sign, would give us a center of 7, negative 2. 1, 2, 3, 4, 5, 6, 7, negative 2. So there's the center of our circle. That's actually not a point on the circle. Okay. This 9 represents r squared. So if we take the square root of both, our radius has a length of 3. So here's what we're going to want you to do. We want you to put 4 points on this circle. And the easiest way to do that, well, if the radius is 3, if we go up 1, 2, 3, right 1, 2, 3, left 1, 2, 3, and down 1, 2, 3, that's kind of the easiest way for us to figure out what this circle is going to look like, and then we do our best to make the most beautiful circle that we can. Okay? Pretty simple. Number 8, maybe not quite as simple. Write the equation of a circle with center 3, negative 1. Well, there's our h and our k. That is tangent to the line y equals 3. So what we don't know the radius. But the information they give us must be able to, or must lead us to, finding the radius. Important that you know what the line y equals 3 looks like. Y equals 3 is a horizontal line. Every single point in the world that has a y coordinate of 3. This one, this one, this one, all of these. Okay, so this is the line y equals 3. The center of this circle is at 3, negative 1. That would be the center of the circle. Now the question is, what is the radius? Okay. Well, if you think about where tangent means that this circle that we're going to draw around the center will only touch this line at one exact point. Now I think if you think a little bit common sense, where would that point have to be in relation to the circle? Wouldn't it have to be directly above it? Okay. If this is a circle, if it touches the circle here, it would touch the line somewhere on the other side as well. The point of tangency has to be this point right there. Okay, directly above from that. That way, when we draw our circle, you see that it is tangent. Okay? Alright, so what's the radius? Let's count. 1, 2, 3, our radius is 4. Radius squared, 16. Okay. Now for a little bit of ease, we only would ask you a question like this if the tangent line was horizontal or vertical. Okay. And for that reason, you should know that the point of tangency, the one point where the circle would intersect with the line, will either be directly above, below, to the left or to the right, obviously if it was a vertical line, the center. And that should make it very easy for you to find the radius. And like I said, we're not grading your graph here, but it's nice to be able to put it on a graph and take a look at what the radius is. Why don't we need the distance formula? Well, this segment, this radius here, is a vertical line, or a vertical segment on this graph. And anytime we have a vertical segment or a horizontal segment, all we need to do is count the number of units to figure out the length of that segment. Okay?